NASA tracked an asteroid that breaks every rule of orbital mechanics. Apophis, a 340-meter space rock, will pass between Earth and our satellites in 2029, closer than any object of its size in recorded history. But here's what terrifies scientists. Its trajectory through space creates an impossible problem called a gravitational keyhole. June 2004. Astronomers at Kitt Peak Observatory detected a new near-Earth object. Within weeks, orbital calculations revealed something unprecedented. This asteroid had a 2.7% collision probability with Earth for April 2029. That doesn't sound catastrophic until you understand the numbers. No asteroid in human history had ever scored higher on the Torino impact hazard scale. Scientists named it after Apophis, the ancient Egyptian god of chaos and destruction. The initial trajectory data showed Apophis would arrive on Friday, April 13, 2029. Global observatories immediately requested emergency telescope time. News outlets ran doomsday headlines.
Finally, the headline on the Forbes website is scary. It reads, "Doomsday Asteroid Bigger Than Expected."
Planetary defense teams convened crisis meetings. Then the calculations started changing. Every new observation shifted the predicted path, sometimes toward Earth, sometimes away. The orbit refused to stabilize. This is where physics gets terrifying. Asteroids don't follow simple paths through space. They experience something called the Yarkovsky effect, a subtle push created when sunlight heats one side of a rotating rock. As that heated surface radiates infrared energy back into space, it generates thrust, like a microscopic rocket engine. Over decades, this force can shift an asteroid's position by thousands of miles. NASA's calculations showed this effect was actively changing Apophis's trajectory, but they couldn't predict exactly how much. Goldstone Deep Space Communications Complex in California aimed its radar at the approaching object. The reflected signals revealed precise measurements, 340 meters mean diameter with a long axis reaching 450 meters, irregular shape, possibly a contact binary, two lobes joined together. Velocity at closest approach, 30.73 kilometers per second relative to Earth. Mass estimates suggested a composition of nickel iron and silicate rock. These numbers allowed scientists to calculate the impact energy if Apophis struck our planet. The released energy would equal 1,200 megatons of TNT. For perspective, the largest nuclear weapon ever detonated, the Soviet Tsar bomber, released 50 megatons. An Apophis impact would deliver 24 times that force. The 1908 Tunguska event over Siberia, which flattened 80 million trees across 2,000 square kilometers, released approximately 10 to 15 megatons. Apophis carries 80 times more kinetic energy. The 2013 Chelyabinsk meteor that injured 1,500 people was only 20 meters wide. Apophis is 18 times larger. Impact simulations painted a catastrophic picture. If Apophis struck land, it would excavate a crater 5 kilometers across and 600 meters deep. Everything within 50 kilometers would be instantly vaporized. The blast wave would flatten buildings 300 kilometers from ground zero. Thermal radiation would ignite fires across an area the size of Belgium. If it struck the ocean, tsunami waves exceeding 100 meters would devastate coastlines across entire ocean basins. Casualty estimates reached into the millions depending on impact location. But the real nightmare scenario involved something astronomers call a gravitational keyhole. During the 2029 flyby, Earth's gravity will pull on Apophis, slightly bending its orbit. If the asteroid passes through a specific region of space, just 600 meters wide, Earth's gravitational influence will alter its trajectory by exactly the right amount to guarantee a direct collision 7 years later in 2036. Think of it as a cosmic bank shot. Miss the keyhole in 2029, and Earth is safe. Thread that 600-meter needle, and 2036 becomes inevitable. This phenomenon occurs because orbital mechanics operates on precise mathematical relationships. When Apophis passes Earth in 2029, our planet's gravity will add energy to the asteroid's orbit. If that energy boost occurs at exactly the right moment, in exactly the right location, it will shift Apophis into a resonant orbit. 7 years later, Apophis and Earth will arrive at the same point in space at the same time. No warning, no second chance. Throughout 2005 and 2006, observatories worldwide tracked Apophis relentlessly. Radio telescopes measured its position to within meters. Optical telescopes captured thousands of images. Each new data point refined the orbital calculations. The probability of passing through the gravitational keyhole steadily decreased. By December 2006, astronomers announced the 2029 Keyhole threat was eliminated. The predicted miss distance was now certain, 32,000 kilometers from Earth's surface. That sounds safe until you realize our geostationary satellites orbit at 35,786 kilometers altitude. Apophis will pass beneath them. Inside our satellite ring, it will become the closest approach of any asteroid its size in recorded history. On April 13, 2029, 2 billion people in Europe, Africa, and Asia will watch it cross the night sky with the naked eye. It will shine at magnitude 3.1. as bright as stars in Orion's belt, moving fast enough to cross the entire sky in less than 1 hour. But the story doesn't end in 2029. When Apophis enters Earth's gravitational field, our planet's tidal forces will stress the asteroid in ways we've never observed. Computer models suggest the object might experience seismic shaking. Surface boulders could shift or tumble. If Apophis is a loosely bound rubble pile held together only by weak gravity, Earth's tidal forces might pull it apart. If it's a solid monolith, it will survive intact, but potentially altered. We don't know which scenario will occur. NASA repurposed the OSIRIS-REx spacecraft for this mission. After successfully collecting samples from asteroid Bennu and returning them to Earth in September 2023, the spacecraft was renamed OSIRIS-REx, short for Apophis Explorer. It will intercept the asteroid shortly after the April 13th Earth flyby. The spacecraft will orbit Apophis for 18 months, mapping surface changes caused by Earth's tidal stress, analyzing composition with infrared spectrometers, and measuring rotation changes with extreme precision. The European Space Agency approved the Ramses mission in 2024. Short for Rapid Apophis Mission for Space Safety, this spacecraft will launch in 2028 and arrive before the Earth encounter. It will accompany Apophis throughout the entire flyby, capturing real-time data as Earth's gravity warps the asteroid. Cameras will record any surface avalanches or boulder movements. Radar will measure shape deformation down to centimeter accuracy. Spectroscopy will detect any outgassing if internal volatiles are released by tidal stress. These missions address a critical knowledge gap. Approximately 80% of potentially hazardous asteroids share Apophis's characteristics: S-type composition, contact binary structure, fast rotation, possible rubble pile interior. If we ever need to deflect an incoming asteroid, understanding how these objects respond to gravitational stress becomes essential. NASA's DART mission proved we can change an asteroid's velocity through kinetic impact, but the deflection efficiency depends entirely on internal structure. Hit a solid rock and you get maximum momentum transfer. Hit a rubble pile, and energy dissipates into rearranging loose material. The 2029 flyby will essentially perform this experiment for free. Nature will subject Apophis to forces equivalent to a major earthquake and will watch from front row seats. Every telescope on Earth that can see the asteroid will be tracking it. The James Webb Space Telescope will observe it in infrared, searching for thermal signatures of internal stress. Ground-based radar will map its shape before and after. Amateur astronomers worldwide will contribute brightness measurements to detect rotation changes. March 2021 brought final confirmation. A coordinated observational campaign involving NASA's Goldstone solar system radar and the Green Bank telescope eliminated all remaining uncertainty. The 2029 trajectory is now known to within a few kilometers. More importantly, astronomers calculated Apophis's position for every subsequent Earth approach through 2116. The gravitational keyhole threat is permanently eliminated for the next century. No impact will occur in our lifetimes. This certainty comes from understanding how gravitational perturbations propagate through orbital mechanics. Every time Apophis passes a planet, that planet's gravity nudges the asteroid's path. Venus, Earth, Mars, even Jupiter all contribute tiny course corrections. These perturbations compound over time. The 2021 radar observations measured Apophis's current position with such precision that astronomers can now calculate all gravitational influences for the next 100 years. The error margin is smaller than the gravitational keyhole dimensions. We know Apophis won't hit them, but here's what keeps planetary defense scientists awake at night. Apophis is just one asteroid. NASA's Center for Near-Earth Object Studies tracks 32,000 near-Earth objects. Of those, 2,300 are classified as potentially hazardous. That designation means they're larger than 140 meters and have orbits that bring them within 7.5 million kilometers of Earth. We discover approximately 3,000 new ones every year. Current detection rates suggest we've found only 40% of potentially hazardous asteroids larger than 140 meters. The asteroid that terrifies astronomers isn't Apophis. It's the one we haven't discovered yet. Objects approaching from the direction of the Sun are nearly impossible to detect because ground-based telescopes can't point that direction without being blinded. The Chelyabinsk meteor came from the solar direction. We never saw it coming. It arrived without warning, exploded over a city, and injured 1,500 people. And it was only 20 meters wide, too small to track with current survey telescopes. This is why NASA is building the NEO-Surveyor Space Telescope. Launching in 2027, this infrared observatory will operate from a position between Earth and the Sun, specifically designed to detect asteroids approaching from the solar direction. Infrared detection works because asteroids absorb sunlight and re-radiate it as heat. Even dark asteroids invisible to optical telescopes glow brightly in infrared. NEO-Surveyor should discover 90% of remaining near-Earth objects larger than 140 meters within 5 years of operation. The Apophis story transformed planetary defense from science fiction into operational reality. When it was first discovered in 2004, no national space agency had a formal asteroid deflection program. No spacecraft had ever intentionally altered an asteroid's orbit. Planetary defense existed only on paper. Today, NASA operates a Planetary Defense Coordination Office with an annual budget exceeding $150 million. The DART mission successfully changed an asteroid's velocity in September 2022. The Hera mission will arrive at that same asteroid in 2024 to measure the results. Multiple nations are developing deflection technologies. We now possess the capability to prevent an asteroid impact if given sufficient warning. Kinetic impactors like DART work for objects discovered decades before impact. For shorter timelines, other technologies exist. Gravity tractors that use spacecraft mass to slowly pull asteroids off course. Nuclear standoff detonations that vaporize surface material to create thrust, even ion beam deflection for multi-decade missions. The technology exists. The infrastructure is being built. What we need most is time, and time requires early detection. April 13th, 2029 will be the most observed asteroid encounter in human history. Billions of people will look up and see Apophis racing across the night sky, a reminder that Earth exists in a cosmic shooting gallery. We were fortunate this time. Apophis will miss, but the universe contains countless other rocks on intersecting orbits. Some we've discovered, most we haven't. The question isn't whether another asteroid will approach Earth. The question is whether we'll see it coming and whether we'll have built the systems necessary to respond. The asteroid that destroyed the dinosaurs struck without warning 66 million years ago. Humans are the first species in Earth's history with the technology to prevent such an impact. Apophis gave us a wake-up call. We answered by building detection networks, developing deflection capabilities, and taking planetary defense seriously. When the next genuinely threatening asteroid is discovered, we'll be ready. Because unlike the dinosaurs, we have telescopes, spacecraft, and the will to defend our planet.